We're going to talk about the molecular or the true formula. Now, this is where all of our pieces come together. So I'm going to do an example problem from this section. We're going to look at number 8. So number 8 says one of the oxides of carbon has a composition that is 42.8% carbon and the rest is oxygen. Well, if 42.8% is carbon, we'll do 100 minus 42.8 to find that 57.2% is oxygen. So I'm going to take those two amounts and I'm going to convert them to moles. So we're going to pretend that these are grams. And I'm going to go 42.8 grams of C. Well, there's 12.01 grams of carbon in every mole of carbon. And I'm going to convert my 57.2 grams of oxygen. There's 16 grams of oxygen in 1 mole of oxygen. So I get that for every 3.56 moles of carbon, I get 3.575 moles of oxygen. Now, if I'm going to divide both of these by 3.56, I mean, really just looking at these numbers, we can tell this ratio is going to be 1 to 1. So my empirical formula is going to be just CO. So we have carbon monoxide. So now the next step of this process is to find my true formula. So it says it is found that 250 milliliters of this gas weighs 0.313 grams. So 0.313 grams is equal to 250 milliliters. So now what I'm going to do is I need to get from grams per milliliter to grams per mole. So how exactly are we going to do that? Okay. We're going to use our conversion factor that 1 mole is equal to 22.4 liters. And we're going to make this number work for us. So I'm going to go boop, 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 and make this instead 0.250 liters. That way, if I'm starting in grams per liter, I can easily do my conversion to grams per mole. So 0.313 grams over 0.250 liters. Now, just as a reminder, whatever we're trying to cancel out, we want to make sure we have on the top and on the bottom. So we want to keep grams the same. It's just liters that we're changing. So I'm going to put liters up top and mole on the bottom because that's what we're trying to get to. Okay. And I know that 1 mole is 22.4 liters. So liters cancels and I'm left with grams per mole. So I do my 0.313 divided by 0.25 times 22.4 to find that the actual mass for this compound is 28.04 grams per mole. So now I'm trying to figure out if that's the case, okay, well, what is my actual formula? So I'm going to find the mass of my empirical. So the mass of a carbon plus the mass of an oxygen, it's going to give me 28. All right, so in this case, the mass of my empirical is equal to the mass of my true or molecular formula. So if I did 28 divided by 28, that's just going to give me 1. So that means my empirical formula is CO, but my true formula is also CO. So now I'm going to go a little bit away from this problem, okay? And I'm going to say, what if instead it told you that the actual mass, so we have the same data. So we're starting with 42.8% carbon and 57.2% oxygen. And it instead told you that they found the actual mass, or the mass of the formula, to be 168 grams per mole. Now, if we know my empirical formula is CO, so this is my empirical, and the mass of that is 28 grams per mole. Now, these are the types of problems we like. When it gives me the actual mass, I don't have to do this grams per liter to grams per mole conversion. I just can work right from this number. So I'm going to take my 168, and I'm going to divide it by 28. And I end up getting 6. So that means my actual mass is 6 times as much. So that means my true, or my molecular formula, I'm going to multiply both of these subscripts, they just both happen to be 1, by 6, and we end up with C6O6. I hope that helps.